Okay, let's start. Yeah, so next speaker will be Daniel. He's coming from Framework, and he will talk about open software on an open convertible laptop. Have fun.
Okay, good morning. I was here last year. Last year I talked about firmware updates on Linux, and this year I talk about this new laptop. Okay, I'm the same person as last year. Still German. I live in Taiwan, and I do software firmware engineering at Framework. Framework is now 5 years old, and we have offices in the USA and in Taiwan. We do most of the engineering here. We do the SMT and the assembly here. So it ships very quickly. This was last year. Last year we had just 2 products. We had the small Framework 13 and even more modular, bigger 16-inch for gaming. But this year we have 2 new products. The Framework 12, what I'm talking about today, convertible with a touchscreen and stylus, and also a desktop, a small desktop for AI and gaming. That's pretty small. You can see it downstairs on the 3rd floor. Okay, what is a convertible? Convertible is basically a laptop, but it means you can fold the screen back and you can touch the screen. But if you fold it back, the keyboard is disabled. What does a convertible do? Yeah, you can fold the screen back, and it enters tablet mode. That means the keyboard and the touchpad is disabled because you hold it from the back. And also the screen rotates in tablet mode if you rotate the screen just like a tablet. Touchscreen also is pretty simple. You're familiar with it. It handles touch events, and we also support styluses. Stylus is a bit more complicated because there are many different protocols: Apple, Microsoft, Chromebook, and then some more proprietary protocols. How does the tablet mode work? How does the system know the screen is folded back? So it has 2 accelerometers. There's one in the top in the screen and one in the base. And based on the angle, or based on the data between them, it can calculate the angle of the screen. And if the angle is beyond 180 degrees, it switches into tablet mode. But there's one edge case. If you fold it all the way back, the angle is basically the same as 0 degrees. 0 and 360 is the same. So you might have the case that it's flipping between closed and fully open. That's why there's an extra Hall sensor that normally you have a Hall sensor in your laptop to determine if your lid is closed or not. But here you have a 2-axis Hall sensor. It can know if the lid is closed from the top side or from the bottom side. And touchscreen is pretty simple. Just like the touchpad, it's an I2C HID interface, HID. And then how it works, the sensors, just like most other sensors, are connected to the embedded controller, the EC, and the firmware handles all of that. For the touchscreen, just like the touchpad, it's connected to the CPU, and HID is a very standard, very old interface, so it's well supported on every operating system. Here's a picture of the first time we powered it on. Just the bare board with the bare battery. And I used FreeBSD because we didn't have the keyboard yet. And my Linux, they all had encryption. So FreeBSD was the only one I could boot to actual graphical interface. And the first time we booted it, FreeBSD could boot. It could boot to a graphical screen. The touchscreen worked. So supporting open software on hardware is pretty easy, actually. These days, everything is pretty mature. Okay, how does tablet mode work? The embedded controller, the firmware, can tell based on the sensors what state is in. But then how do you communicate that to the operating system? I had previously used a Linux laptop convertible before, but I didn't know how, or like 10 years ago, it didn't really work. So I didn't really know what to do. I did research and I saw many, many different approaches. I saw people writing daemons in many different programming languages. So it looked like total chaos. And if you have a custom daemon, but everybody uses GNOME, KDE, or similar, how do you tell them what state you're in? Then also I found there's ACPI. So if you're confused, I was confused too. ACPI sounds simple, but there's like a standard looking one. Then there's 3 different ACPI devices that Intel uses. There's one from Google that they use on Chromebooks. There's 2 from AMD, 2 on Lenovo. I found so many different things, I didn't know what to do. And finally, I think one of our BIOS engineers realized that the standard one, we just tried it. We just copied from something else. And it just worked. So it looked really complicated, but it was actually not. This is all of the ACPI code that we need for this. It looks complicated, but it's not. You just tell the OS that you have this kind of standard device, the PNP, and you tell it it's connected to this GPIO, and OS could figure out everything by itself. Same on Windows. Windows has a driver. If it sees this ACPI device, it loads the GPIO laptop and slate indicator driver, which also just works. The Microsoft documentation looks pretty confusing, but luckily everything just works. Then tablet mode is working. Tablet mode just means tell the OS, are we in tablet mode or not? It's just a binary flag on, off. Then on top of that, you want the sensor to know if the screen is rotated or not. For that on Linux, we use, for the embedded controller, we use the same as Chromebooks. So it has host commands where the CPU can talk to the embedded controller, and Chrome OS is just Linux. So Linux has a driver already, which means we don't have to do anything. We just added our hardware ID, and we're good. Windows is more difficult because there's no Chromebook with Windows, obviously. So we had to write some drivers, except there's a person, Coolstar, and she has wrote some drivers for Windows already. She got Windows running on lots of Chromebooks, so she made a driver to talk to the EC already. Except she didn't make one for the sensor, so I did that. I just took one of the Microsoft samples and I hooked it up to the EC communication. And it worked pretty easily. Yeah, Microsoft, they publish open source samples. They have a GitHub repository, and under a very free license. So that's pretty nice. They don't have much documentation for it. They just post the code, and you're on your own. But then you have the code. You also need to build it and ship it to customers. So it's quite different than Linux. First, you build it with Visual Studio. You could build it with the command line, but you always have to install the Microsoft Visual Studio tools. And then to debug the kernel, you have to get a special USB-A debug cable and use 2 machines, connect them together, and run the Microsoft debugger. But then when you have the Windows driver, to run it on users' machines, you need to get it signed by Microsoft. They have gotten more restrictive about what you can run on your Windows, especially because of CloudStrike and so on. Many people write bad Windows drivers, and everybody blames Microsoft, even if they're not responsible. So to publish a Windows driver, you have to run a lot of tests. They call it HLK. That's another complicated setup where you have to run this software suite on one computer connected to another, and it runs for a day and does some tests, and then you get a result. If that's positive, you sign it with your expensive EV certificate. We had one already, but it didn't really work. And after a few weeks, we found out that we had to get a different RSA certificate, which cost another couple $100 US. And then you upload that to the Windows Hardware Quality Lab page. It's kind of like the iOS upload page where you just wait for Microsoft approval. And luckily, they just approved it without comment. So that's good. Let's summarize how everything works. First, the embedded controller reads the sensors, the Hall sensor and the accelerometer, and based on that, it can calculate the lid angle. Then if it determines the angle is tablet mode, it sets a GPIO that's connected to the CPU. And we saw the ACPI earlier. If this GPIO is set, the OS gets interrupted. On Linux, that's the name of the driver. On Windows, the laptop and slate driver. And then this ACPI driver notifies the desktop environment. On Windows, we don't know how it works, but on Linux, the kernel sends like a key code, this software tablet mode key code to the system, and then GNOME and KDE and so on, they can also lib input, they can read that and do whatever they need to. So the desktop manager switched to tablet mode. On KDE and Windows, you can see that. You can see the taskbar gets smaller. You know if you're in tablet mode or not. On GNOME, nothing happens, so you don't really know. Then to rotate the screen, the OS accelerometer driver reads the sensor data of the lid. To get the screen rotation, you only need one sensor. And then on Windows has an extra driver that loads if it sees an accelerometer driver that calculates the lid angle based on the G-sensor data. On Linux, there's a software package IIO sensor proxy. It calculates the lid angle and then sends a notification to the applications to rotate the screen. Right. Yeah, for touchscreen, there's not really much to say about the finger touching. It just works. For the stylus, we're going to ship a stylus, and the main protocols are MPP from Microsoft and USI from Google. They are basically the same. In the beginning, we thought that maybe only Microsoft works on Windows and USI on Linux, but because in the end it's just an HID device, it looks the same to the OS. The OS doesn't even know anything about the underlying protocol. So just like everything else, in the beginning everything looked scary, but it just works. The only difference really is that USI it can report the battery level of the stylus. So that's pretty useful, that you know how much battery you have left. USI, they say they're an open standard, but you can't really get any access to any documentation if you don't pay to be a member. So it's not really very open. Yeah, I said you want your keyboard and touchpad to be disabled. The embedded controller does what it can do, because for Chromebooks they have done that already, and the keyboard is connected to the EC, so keyboard gets disabled. And on Linux, lib input gets the event from the kernel, and it disables the touchpad and keyboard as well. But on Windows, Microsoft just says the hardware vendor has to do everything. So In the beginning, I tried to write a daemon, like a software application to handle that. But then you need to make sure people have it installed and it can crash and so on. So it didn't seem like a good solution that we can ship to customers. But what are the other options? The touchpad is connected to the CPU, so the EC can't really do anything about it. And we ended up, just for Windows, adding a GPIO to the touchpad and connecting that to the EC so that it can disable the touchpad in tablet mode. And that also required a firmware update to the touchpad. And we're also able to update the firmware of the touchpad and touchscreen on Linux. And we get that for free because Google forces every vendor that ships Chromebook devices, peripherals, to publish open source code to update the firmware, which is really great. How much time do I have? Okay. I mentioned this IIO sensor proxy. It talks to the kernel driver to get the raw G-sensor data, and then it interprets that as the screen rotation angle. Well, not really angle, it's just as you rotate in this 90 degrees or not. But just before we shipped, they had a new version which introduced a regression and made it break with the kernel driver that is used on Chromebooks and our systems. And it looks like there's a bug in the kernel where the kernel says it can support buffered mode. So the proxy tries to use that, but then no data comes out. And kernel updates propagates really slowly to distributions. So we first looked into how to fix that on the software side. And it turns out that somebody submitted an issue the day before I noticed, because he was running it on a Chromebook. And I proposed a few different ways to fix it, but the contributors are also really active, and they found better ways to fix it in a general case. And but they don't release it very often, so I submitted the patches that they merged upstream to the different distributions and make sure that they get it in before our release. So if you buy new hardware, it's always good to use a distribution that updates frequently, like Arch, NixOS, Fedora. If you use something that updates more slowly and you have new hardware, then of course things are not going to work. Yeah, and I said they release slowly, but just before the talk I checked, and they released a new updated version with the fix last night. So just before the talk I pushed the fix to Nix packages. And if you have a favorite distribution that you can contribute to, you can update that, make sure it gets updated. Yeah, the summary is it's pretty easy to support Linux for any kind of hardware. Most things just work out of the box. And new types of hardware is fun. It's interesting to learn about. And you can learn about how it works on our system. You can look at our EC code online. There's no special code in the BIOS. The ACPI code is, you can dump it from the system. So it's basically open source. Yeah, you can, yeah, that's it. You can, if you have any questions, you can ask me or you can find me later. We also published some hardware documentation on GitHub, the interfaces of the system. So just like our other system, you can build custom modules if you're into hardware.
Any questions?
Sorry, when does this product ship?
I think it ships in a few weeks.
How much?
I think it starts at 16,000 Taiwan dollars, like 500 US. Yeah, it's the entry-level model for kids, for students, or for anybody who wants a smaller laptop, who wants a touchscreen. Yep.
Can I still do a trying to just put a
Magnet?
yeah magnet sheet under the secret disk and just let it not work?
Sorry, what do you mean?
Just put a magnetic sheet below the laptop and it will disable keyboard and stuff.
Yes, if you put the magnet in the right place, yeah, yeah. But I made some tools where you can trigger that by yourself. So if you could use it like just like this and connect it to a screen. By default, the keyboard is disabled, but I made a tool where you can say, keep it enabled, and then you can save space on your desk with the external screen and just type like this. You don't need a magnet to do that.